Hello and welcome to JS Tube. So today we are also continue working on JS exit exams in the course of JS and remote sensing that will help students to score better results in upcoming exit examinations conducted in higher educational in universities of Ethiopia, so that you can use as a reference material for your practice. So question number one, the process of converting raster data to vector data is called A, reclassification, B, rasterization, C, vectorization, D, overlay analysis. Correct answer is vectorization. That is converting raster into vector. Simply is called vectorization. Okay. Question number two, geostatistical analysis methods are primarily used to A, classify satellite imagery, B, understand spatial dependencies in data, C, create 3D visualizations, D, design user interface for JS applications. So geostatistical analysis is primarily used for understanding spatial dependencies in spatial data for ArcGIS environment. Okay, great. Question number three is the method of assigning numerical values to areas based on proximity to a central feature is called A, buffering, B, Voronoi analysis, C, smoothing, D, clipping. So this proximity theory is then applicable for buffering analysis. Okay, great. Question number four. The interpolation method commonly used for environmental data prediction is A, Kriging, B, nearest neighbor, C, spline interpolation, D, binary interpolation. So these are algorithms, the others are algorithms, but Kriging is the methodology and the others are algorithms. Uh, so the answer is Kriging. So it is common for predicting unknown places using known variables. Okay. Question number five. Remote sensing data with higher number of spectral bands typically provides. So if there is remote sensing data with higher numbers of spectral bands typically provides A, better spatial resolution, B, enhanced radiometric resolution, C, more information about surface materials, D, faster image acquisition. So the answer is more information about surface materials. If we have more spectral bands in your remote sensing data, you have the chance to collect more information about surface materials. Hyperspectral remote sensing is a good example which has more than 100 bands, more than 100 spectral bands within this type of remote sensing. Okay, great. Question number six. Primary benefit of LiDAR data in remote sensing is A, accurate topographic surface representation, B, identification of vegetation health, C, monitoring of air quality, D, detection of urban sprawl. So LiDAR means light ranging and detecting radars, which is a perfect representation of or analysis of topographic surface and topographic landscape surface features. Okay, great. Question number seven. The integration of vector and raster data in GIS is known as A, topological modeling, B, hybrid data analysis, C, raster-based modeling, D, geospatial modeling. So this is hybrid data analysis. If we combine raster and vector data in GIS, we call it hybrid data analysis or the combination of two data models in GIS. Okay, great. Question number eight. The process of adjusting image brightness and contrast to correct for illumination effect is called. So this is digital image processing steps. So in digital image processing, we have the steps of pre-processing. So this pre-processing of adjusting image brightness and contrast to correct illumination effects of light is called a radiometric normalization, B, atmospheric correction, C, geometric rastrification, D, spectral enhancement. So the answer is radiometric normalization. Okay, great. Question number nine, land cover classification using remote sensing typically requires, if we are going to classify land use land covers using remote sensing data, so what is required? A, only image enhancement techniques, B, combination of supervised and unsupervised learning, C, high spatial resolution data only, D, temporal analysis of multiple images. So the answer is combination of supervised and unsupervised learnings. Question number 10. Temporal changes in vegetation are best monitored by using blank. Temporal changes in vegetation means there is time difference. That means time-based changes, time-based change detection analysis of land use land cover, or vegetation means we have two time periods where we require two time period image acquisitions. So this can be based monitored by a thermal infrared data, B time series analysis of NDVI, C topography data, D radar data. So this is time series analysis of NDVI. Within different time intervals, we are going to analyze normalized vegetation indexes. Okay. Question 11. The process of removing spatial errors from GIS dataset is called data cleaning, topological validation, data transformation, data harmonization. So the correct answer is topological validation. This topological validation is removing spatial errors from GIS datasets. Okay. Question number 12. The method of combining multiple rasters based on a mathematical expression is blank. So this is a method of combining multiple rasters. That means more than one rasters together is called A map algebra, B vector overlay, C network analysis, D array classification. So the answer is map algebra. In map algebra, there is a calculation, there is calculator algorithm. In calculator algorithm, we can compute several mathematical operations in raster image analysis. Okay, question number 13. The use of spatial analysis to predict future land use pattern is an example of A. Geospatial modeling, B. Terrain analysis, C. Image classification, D. Network optimization. So the use of spatial analysis to predict future land use land pattern is called, this is modeling. Typically, examples of geospatial modeling. This geospatial modeling combines remote sensing GIS and GPS datasets as an input for determining the status of future land covers of a certain area based on the current analysis of land covers. Okay, great. 14. A method to determine suitability of land for a specific purpose based on multiple criteria is A. Multiple criteria decision analysis, MECIDA, B. Overlay analysis, C. Cost distance analysis, D. Buffering. So the answer is multi-criteria decision analysis. This multi-criteria decision analysis, or MECDA, compares multiple factors that are responsible for suitability of land for a specific purpose, such as crops for a specific crop like wheat and F. So we are going to analyze different types of spatial data in a model for determining the suitability of this specific crop for this specific land. Okay, 15. Overlay analysis in GIS is used to find spatial patterns and trends. B. Combine multiple data sets based on spatial relationships. C. Convert vector data to raster data. D. Analyze temporal changes in spatial data. So we have to understand that overlay analysis means that we are going to compare multiple factors and combine more than one data sets together. So the answer is combining multiple data sets based on spatial relationship to determine certain trends and analysis in GIS environment. Question number 16. The operation that merges two or more polygons into a single feature is called A. Dissolve, B. Union, C. Union, D. Intersect. So the operation that merges two or more polygons in a single feature is called uh, dissolve. Question number 17. A tool used to create zones of influence around a point, line, or polygon feature in GIS is known as A. Buffer, B. Reclassify, C. Merge, D. Interpolate. So the answer is buffer. It is buffering, which creates a certain distance on around a point. Question number 18. The process of creating continuous surface from point data in GIS is called spatial interpolation, network analysis, georeferencing, data transformation. So the process of creating continuous surface from a point data in GIS is spatial interpolation, network analysis, georeferencing, data transformation. So the correct answer is spatial interpolation. This spatial interpolation is responsible for predicting unknown areas using unknown points, or values. So it is called spatial interpolation. Question number 19. Radiometric correction of remote sensing data adjusts for geometric distortions, atmospheric interferences, temporal variations in data, spatial misregistration. So the answer is atmospheric interferences, which are an obstacle in images of remote sensors. Question number 20. An active sensor used to measure the surface through emitted energy is A. MODIS, B. Landsat, C. LIDAR, D. AVRS. So the answer is LIDAR. This LIDAR is active remote sensing satellite images, whereas MODIS, Landsat, and other sentinels are passive remote sensors. Question number 21. In remote sensing, the use of high resolution panometric band in combination with low resolution spectral band is known as a fusion, spatial enhancement, image specification, image restoration. So we have high resolution panchromatic in the case of Landsat 50-meter resolution and multispectral images 30-meter resolution. So in the combining this is called image fusion. This is a type of combination or merging or alignment. Okay, great. Question number 22. In remote sensing, an image acquired in the visible and infrared regions of the spectrum is typically used for detecting water bodies, B. Vegetation monitoring, C. Monitoring land changes, C. Soil moisture estimation. So the answer is vegetation monitoring. So image acquired in the visible and infrared regions of the spectrum is typically used for change detection or land cover analysis. Okay, great. Question number 23. A sensor's ability to distinguish between small difference in reflectances used as a spatial resolution, spectral resolution, temporal resolution, radiometric resolution. So the answer is radiometric resolutions. Able to distinguish between small difference in a reflectance. As we have seen in the previous question, the number of bands increase. It is used to distinguish features on the surface. Question number 24. The reflection of radar waves from the Earth's surface is utilized in A. SAR or synthetic aperture radar, B. Thermal infrared sensing, C. MODIS imaging, D. LIDAR mapping. So the reflection of radar waves is responsible for SAR or synthetic aperture radars. Okay. Question number 25. An example of environmental application of remote sensing is A. Estimating carbon storage in forests, B. Tracking satellite positions, D. Enhancing image resolution, D. Measuring soil temperature. So the answer is estimating carbon storage in forests. 26. The interpretation of SAR or synthetic aperture radar images primarily involves analyzing. So these SAR images or radar images are typically responsible for what? A. Backstar signals, D. Temperature, B. Temperature gradient, C. Light reflections, D. Geometric shapes. So interpretation of involves what? Backstar signals. This backstar signals is a method of pre-processing of synthetic aperture images. So synthetic aperture images passes these processes. Question number 27. A spatial database is used to store only raster data, both raster and vector data, C attribute data only, D temporal data. So both raster and vector data is represented in spatial database. 28. In GIS, spatial join combines two layers based on attribute data, two layers based on their geographical relationship, C spatial data with tabular data, D vector data with raster data. So the answer is two layers based on attribute data. So we have two layers that have attribute tables So in spatial join, we have to connect two layers based on their attribute information. Okay, question number 28. 29. A topological model in GIS ensures correct geometric features of spatial features, better visualization of 3D landscapes, consistent raster data conversion, efficient remote sensing data storage. So the answer is correct geometric feature for spatial features. So geometrically, we are going to arrange topological models. Question number 13. Which of the following is a typical application of GIS in environment management? A. Optimizing landfills locations. B. Tracking animal migration patterns. C. Modeling changes in which cover over time. D. All of the above. So the answer is all of the above. All of the above means we have these environmental issues. These environmental issues including tracking animal migration patterns through a geographical area. Question number 31. The integration of remote sensing data and GIS in flood risk mapping typically involves estimating precipitation patterns by identifying floodplain areas using elevation models and historical imagery. C. In monitoring weather patterns in real time to predict future weather conditions. So typically involves identifying floodplain areas using elevation models and historical imagery is a prerequisite for modeling GIS in flood risk mapping. So this is the primary focus in order to map flood hazards and risks of a certain area. So this is what we have today. But if you are new to this YouTube channel, please subscribe. Thank you for watching.